All right, there are the two problems on the screen now. Warm-up exercise 3 and 4. If anybody has the solution for number 3, you can show it to me by turning the camera on and putting it against the camera. All right, nobody has a solution from.
I do, just 1 second.
You do, okay. Can you put it against the camera?
Yes. Hold on, I'm just fixing my camera real quick. Almost done.
Okay.
I plug it in. Okay, here.
Okay, I see that. Equal to, and then times. Right, very good. But you're missing the semicolons. At the end of each statement, you need semicolon.
Okay.
Okay, one student has the solution right for warm-up exercise 3. If anybody else has the solution, please show it to me. And Anissa, please work on exercise 4. All right, nobody else has a solution for number 3?
I do.
All right, okay, go ahead. Put it again.
91.
You don't have it?
91.
Okay, whenever you're ready. Okay. Put that page against the camera. You have everything in one statement? No, you're not supposed to write, whenever the X and Y in the problem represent variables. So you must use variable names to store the values of X and Y. So you need at least 3 statements. Assigning 7 to X will be one statement.
Professor, can I show you exercise 1 on the computer? Not handwritten. I just did it on the program.
What? It's on the computer screen?
Yeah, it's on the program. I didn't handwrite it.
Okay, then I won't be able to see it.
No, I'm saying you can I share the screen so you can see.
Okay, then I have to allow that. Hold on, let me see if I can allow that. It normally doesn't allow everybody to share. So I'm gonna multiple, okay. Okay, now I have allowed you to share it. Go ahead.
Professor, you see it now?
No. Anyway, we're not on problem one. You know, we went over that those two problems in the last class.
Okay.
So I really want to see problem 3 and 4.
Okay.
Okay, and do it on a paper so that you can show it to me. It
All
doesn't.
right.
It doesn't take several. It doesn't take a lot of work. It's just 3 lines. 3
Okay.
lines. All right. Anybody else with the? These are very elementary exercises. If this is too hard, then you know you really can't continue with this class. So I want to see your solution for number 3. I only have seen one student with the solution.
Professor, can I show number 3?
That's why, please. Okay. All right. Let me see. You have x, y.
Is 5 times x.
Yeah, that's the expression 5 times x plus whatever. That has to be assigned to a variable. You need a variable on the left side.
Oh, yeah, 5 times 7.
No, you need another variable, a third variable, like z or and something, to which you had to assign that expression. Okay, that's missing. And also you're missing semicolons.
Okay.
So the last line needs to be an assignment statement, but it is not assignment statement. Okay? See
Okay.
if you can correct it.
I have it.
Okay. All right. Anissa, you have another one? Okay.
This is 3 here.
Oh, number 3. Okay. X equal to, and okay, almost right. Except
Professors.
5x, we write in algebra, you write it as 5x, but in C++, you had to write the 5 times x. The
Okay.
asterisk would be necessary between 5 and x.
I got it.
Okay, so that's good. At least
So, Professor, you want us to do warm up exercise 3?
3 and 4.
Professor, could I perhaps write the answer in the chat?
Okay, yeah, that's another way. Yeah, you're right. Okay, go ahead.
Professor, could I see the question?
Okay, yeah, sure. I had to go into chat. I had to switch. Okay. All right, there's the chat board.
Professor, what about this?
Okay, the last line, you have an expression, but it needs to be assigned. That expression has to be assigned to a variable.
The expression is not assigned to A and S.
Yeah, you can do that.
Yeah, right here. A and S.
Is that what you have?
Yeah.
I'm not seeing it. I'm not on the paper. Okay, I'm sorry.
Yeah, it's on the paper.
Y equal to 8 and right, you got it.
Okay.
Yeah, you got it.
I forgot to add the semicolon for the last one.
Okay, I'm now looking at Anissa's work. Okay, the assignment has to, the and's equal to has to be on the left side.
Okay.
Okay.
Okie dokie.
All right. Okay, now I'm looking at Sam Ryken. Yes, that's the expression is right, but before that expression, you had to assign values to X and Y. So there will be 3 lines in the program. You only have 2 lines. That's Sam.
Hey, Professor, I tried number 4, exercise 4.
Okay, go
You
ahead.
didn't answer. Wait, I'm sorry.
Exercise 4, X equal to that. And it's equal to that. No, you cannot write the double assignment like that. The last statement is wrong.
Okay.
Assignment can only be one thing assigned to something. So the equal sign, you can only have one equal sign in a statement.
I have number 4.
Okay. All right. Mohammed, show me the assignment 4, the exercise 4. Equal that. Right. Okay, you got it. Muhammad got it right. Very good.
Professor, I did 3. If you're still looking for that.
Yes, I'm still checking number 3. Go ahead, show me. Okay. Equal to yeah, you have Z equal to that, and then you have something else after that. What's that? C out? The 2 lines after the Z equal to should not be there. Okay, other than that, it's correct. Okay, I'm going to go ahead and show you the number 3, exercise 3 on the board. So let me put that away. Okay, I'm doing exercise 3. You need to first assign the values of X and Y. So I'm going to have to write that X equal to 7, semicolon. That statement stores the 7 in a memory cell and names it as X. Now, the next one is Y. The variable Y needs to be 80. Okay. Now, so you have to individually assign values to variables. And then use those variables in your expression. So you cannot use the numbers directly. You must use variables. Someone has a radio on. Is that Karen? Can you turn that off or shut down your mic? Okay, thank you. So now the next expression has to be evaluating the 5x plus 2y. So I had to write it on the right side. The assignment goes right to left. So the expression has to be on the right side. 5 times x. Every multiplication must be clearly identified. You cannot write 5x, which we do in algebra, but not in C++. Plus 2y, 2 times y, and then plus 20. This is the expression, and it needs to be assigned to a variable. Every statement has to be, every expression you compute has to be assigned to a variable name so that it goes into a memory. So I can call it ans or z, it doesn't matter. You need semicolon at the end of that.
I got a question.
Yeah.
Can you add the parentheses or it's just redundant?
You don't need any parentheses, but if you put parentheses, that's not going to be wrong like this. But why do you need that? I mean, multiplication is going to be done before the addition. So
Correct. Okay. So it doesn't, you really don't need it. All right.
At this point, let me explain how to tell the system to write the value of a variable on the screen. To ask the system to write the value of a variable on the screen, you need to write C out. It means C language output. That's essentially what it means. So C out, and then this arrow, the two inequality symbols, we read it as arrow. Two of them have to be there, and then put the variable name on the right side. This means write the value of this variable on the screen. So whenever this is executed, it'll display the value of that wherever the cursor on the screen is, wherever the writing can be done next. So if you want to manipulate that output to make it more clear, and you have to write other things, which we'll discuss later. So right now, we just need to know how to write the output on the screen. So this program right here will compute the value of 5x plus 2y plus 20 and write the value on the screen. Okay, so this is exercise 3. And exercise 4, I have seen 2 students doing it, and one of them was right. So anybody else has a solution for this exercise 4?
I have a solution.
Okay, let me see.
I do too.
Okay, let me see one at a time. Now I'm seeing Sherman. Yeah, closer to the camera, please. Okay, that's good. That's good. Move it down a little bit. Down. Okay, there we go. You're copying them and then copying these. You don't need a cout statement, and also, no, it's not doing it. You're copying them into 2 other memory cells, and then after that, I don't know what you're doing there, but it's not doing the job. The job is this. Let me explain what exactly we're trying to achieve. There are 2 memory cells, DAB and DOC. Let me use boxes for the memory cells. DAB, another memory cell has name DOC, and it has some value. So let's say I'm making up some numbers just to give you an example. So let's say I have 7 and 5 in these memory cells. You're writing statements that will swap these values. That means after your statements are executed, DAB should have the 5, DOC should have the 7. Okay, these values should be swapped. So the problem indirectly means DAB and DOC already have some values. So you don't store any values there. You just write the statement that will swap those values. Okay. Kevin, you're saying you're confused about what? Which problem? Number 3? Number 3, okay. The values of X and Y are 7 and 18. And we need to, I'm explaining number 3, but others can go ahead with number 4. If you understood number 3, then you just go ahead and do number 4. So I need to first store the numbers that needs to be used in the expression. So that's what this X equal to 7 and Y equal to 18. I assume you tried the problem. Problem exercise 3 says, write C++ statements to compute the expression 5x plus 2y plus 20 for X equal to 7 and Y equal to 18. So the value of X is 7. So we can use a memory cell called X to store the 7 in it. And then value of y is supposed to be 18. So I use a memory cell called y and assign 18 to it. So these are two memory cells now holding 7 and 18. So x and y are the names of them. And after that, if I write 5x, that means multiply the value of x, the 7, by 5. And if I write 2y, then that means multiply the value of y, which is 18, by 2. And then plus 20 means add 20 to it. So it will calculate this expression for these values, x equal to 7 and 18. And then I have to assign it to a variable. That's how the computer program goes. You know, everything you calculate, everything you calculate in the program has to be stored in a memory. So that's what this says. Calculate this expression and store it in ANDs, a variable called ANDs. So ANDs will represent another memory cell where your answer is there. The answer would be, we don't need to calculate the answer. That's a calculation is what the computer is going to do for us. But you write this expression, but I'm just to show you, I'm doing the calculation. 10 and 2 times 18, 36, 46, 66 is the answer. So this expression will be computed. The value will be stored in the memory cell called ANDs. So there'll be 66 going in here. So cout ANDs will show the 66 on the screen. It'll just show 66 on the screen. That's all you're going to see as a result of this statement. So that's how that program goes. So Kevin, you got it? Okay. All right, so that's number 3. Now, anybody has number 4?
I think I do.
Okay, 1 second. Okay, let me see one more time. Okay, you got it. Very good. You're missing semicolons.
Oh, I keep doing that.
Yeah, you have to get the habit of that. But yes, you have the right answer. One student, 2 students so far have the right answers. Anybody else? But Anissa, you can actually do it using 3 statements. You wrote 4 statements. You know, it's not a big deal. It is correct, but see if you can write it with 3 statements just to understand it better.
Okay.
I also have an answer.
You have an answer? Okay, go ahead. Dab. No, you're storing your own strings into dab and doc. No, you got it wrong. No, that's right. That's not right. First of all, we are not working with strings here. You cannot use character string as data. We are working with 2 memory cells called dab and doc that have some numeric values. They already have some values. You're assigning values to the variables. That's wrong. If you write, if anybody writes something like this, dab equal to 7, you're erasing the value that was stored in dab. You can't do that. Already there is a value in dab and we don't know what it is. So we don't want to erase that. This statement is wrong. You cannot write that. Okay, so all right, so let me proceed now. I have seen 2 students with the right answer.
Professor, I also have the answer for 4. Kind of sure.
Okay, go ahead. Okay. X equal to, and equal to I think you meant to write the last statement reversed. You have y equal to dark, should be reversed. Dark equal to y. I think that's what you meant.
Yeah, I
Uh,
mentioned. Yeah.
I
That's
think I got it. I'm gonna
Yeah.
show you.
No, you got it, but you wrote the last statement in the wrong way. The assignment goes right to left. So the variable to which you are assigning a value should be on the left, okay?
Can I show you mine, maybe, if you want to see?
Okay, Christopher, go ahead. X equal to y equal to. No, you misunderstood. You are writing them in the reverse order on the screen.
Oh, okay.
We don't even need to write them on the screen. We just need to
Okay.
have those memory cells changed.
Okay, gotcha.
Yeah, that's not right. All right, I'm going to, so basically, the question says, write C++ statement to swap the contents of the two memory cells, dab and dot. That means, that indirectly means these memory cells already have values and you cannot erase them. You need to write only the statements that would swap those values. All right, I'm going to show you on the board. This is a memory cell. Let's say this is, I'm just, to explain, I'm drawing this. You don't need to do this when you're doing the problem. So if this is DAB that has some value, and this is dark, another memory cell that has some value. We don't know what those values are. We are only writing the statement that will swap these two. So if you started by saying something like DAB equal to dark, that's a common wrong way students would write. That right there erases the value of DAB. You're copying dark into DAB. When you do that, DAB will be erased and you lost that value. Once you lose that, you cannot get that. You don't know what it is and you cannot get that. So you should not erase it. That means this is wrong. So what we should do is we should save one of them in a memory cell, in another memory cell. So I'm going to use another memory cell called T, means temporary storage, and copy DAB into this first. How do I write that? T equal to DAB. That means copy DAB into T. T is another memory cell. If you make up any name and use it in the program, it automatically becomes name for a memory cell. So the T is another memory cell. I'm copying DAB into it. So now DAB has been saved here. After that, I copy doc into DAB by writing DAB equal to doc. So now doc has been copied in here. After that, I need to copy the T into doc. So doc equal to T. That's what you need to achieve this. Three statements. Basically, one of them needs to be saved somewhere, and then move a copy of doc into DAB, and then the saved value will be copied into doc. So this will swap. This swapping business will become part of larger programs later on, larger programs, multiple programs. So that's why I wanted to do that at this point. So remember, whenever the problem says, variables have values already, then you don't change those values. You need to write the statements which would use those values and achieve whatever we need to achieve. Moving on to next section, unless anybody has any question on this. And also you were expected to read the homework that was graded, and you're supposed to bring up any question on that homework for discussion. Anybody has any question on that? Anybody has a question on homework, or anybody wants me to explain this number 4 again or anything like that? Bring it up.
I have a question, Professor.
Yeah,
So
go ahead.
I noticed that whenever you make it available on the homework assignment, the questions are different from the questions that you assign on the slides. So like you'll be like one question off. So I just do the questions on the slide because that's what I see first, and then I submit it. So is that an issue or no?
This presentation, you mean? This
Yeah.
PowerPoint presentation? Yeah, that you don't use the problems assigned here are not always correct. So not the presentation. The correct number of problems that you need to submit are always there at the link. The link where you submit, that tells you exactly what problems should be submitted. Okay, that's what you go by. This slides is was prepared a long time ago, and the course has evolved so much after that. And so the exercises that are on this presentation, the PowerPoint presentation, are not always correct. The exercises at the end, the homework assignments. Okay, the correct ones are the ones at the link. Now I showed you before, so let me show you one more time. If I can go there. Okay, I can go to the Blackboard. If you go to submit assignments right there, that takes you to the Turnitin. This is Turnitin page. And exercise homework 2 right there. It tells you the problems to be submitted for homework 2, and what time it is due, and everything is right there. Okay, this is the correct information. Always perfectly accurate information would be here. So your next assignment is indicated right here. The assignment to be submitted today is this. You must have submitted this morning, and these are the numbers. It's all clearly stated here. So to submit, there was one student who said he didn't know how to submit. So I'm showing that one more time. You click at this view complete, and then you enter your information here, your first name, last name. I get the names of all the students right here. I don't know whether you get that or not. You can select your name if you're in the list. Otherwise, you type your name. And then you had to put a title for the homework. So let's say homework 3. And then you click at this to choose from your computer. So if you click at this, it'll bring up the list of everything in your computer. You select what you want to submit. So after that, so I'm going to just, no, I'm going to close that or cancel it. So you select the file, and then down here, upload button is there. So once you select the file, it would bring it up right here on the side. No, actually, after you select upload, it'll bring the file here. So if the upload is going through correctly, then you'll be able to see the file displayed right on the screen. And if you're not seeing it, that means it's having trouble uploading it. Sometimes if it is having trouble uploading it, it will attach it as an attachment to the assignment. If it does that, then I can download. I have to download it to see it. If I have to download to see it, then I can see, but I won't be able to write my feedback on that. So it won't work. The grading will not work properly unless you upload it. So if it fails to upload, you just have to try again or convert the file to some other format. If it is a picture, convert it to PDF. You can do conversions and then try. but it has to be uploaded so that I can write my feedback. So this last assignment that I graded, most people had it uploaded properly. Only one student had some trouble. It was not uploaded, it was attached. So I had to download and then convert it and then upload it. You know, I did that work, but I can't do that for too many of you. I can usually download and then convert and upload, but then, you know, it'll be too much work if too many of you have that problem. So you had to try and upload it yourself. This assignment system is very good. It usually accepts file in any format. So you should keep trying, it will eventually work. All right, so I'm closing that. All right, you got it. The numbers, this number of problem, the problem numbers to be submitted are right there, and that's what you use. These are the correct number of problems. So my course calendar, which is right here, is supposed to tell you what is due after each class right here. Section, this is today class is class 4, it says 2.1. Now we are off from that. You know, we already had some of the problems from 2.1 submitted already. So it's very hard to stick to this plan right here. So that's why you cannot trust this entirely. You have to rely on the numbers shown on the submit assignment section right here. These numbers are the correct ones. All right, so any other question?
No, that's fine.
All right, great. So I'm moving on now. I assume everybody understand my feedbacks on your assignment and assume that you understand how to do it correctly. You know, these homework problems are basically your guidelines for your test questions. You know, these are the kind of questions you will be asked in the test. So always understand how to do these problems correctly, then you'll be fine. You'll be doing good. Let me erase this and go to the next topic. Okay, I was going to go over the program, running a program today, but I couldn't get the setup to work properly. Remember, I had to do it in a Windows computer, not in the Mac, because the software we're going to use is only available for Windows. None of those software out there, the compiler software, work on Mac. Only one that works on Mac is called the Xcode, and you already have it. If you're a Mac user, you already have it. Just go to apps and find the Xcode and run it. And if you don't know how to use it, I have a document posted on the Blackboard in the supplements section that tells you how to use Xcode. So anybody wants to use it?
That's a good, Professor, because a couple of us do not have our textbook yet.
Oh, I see. Yeah, you know, it's I have permission from publisher to provide chapter 1, but not chapter 2. You know, they.
Yeah, unfortunately, I had to apply for a book voucher through John Jay. I just received it last night, and I made the order, so I should have my textbook by early next week.
All right.
And there is one more student that does not have his textbook as well.
Okay. Both of you send me a message. I will see if I can send you an older edition of chapter 2. Yeah, the problems will be still same. Okay.
Okay, great.
I think there's a version of it online.
And I also advise.
Yeah.
Chapter 2.
Can you send me that message, Anissa, if possible?
I gotta look for it. Just give me a minute.
Okay, thank you.
So if you send me the message, I will reply it and attach that older edition of the chapter 2.
Okay, Professor Kugan. I also sent you a message, and I wasn't able to complete the homework last night, but I can always update the homework for you and send it to you through email.
Okay, then after you get the chapter 2, you add the solutions of the chapter 2 to that assignment that you work. You have to give me the one document. So attach the new solutions and then send me the new document. I'll upload it for you. Okay.
Okay, great. Thank you.
Okay, so Kevin had a little problem. So because of that, I'm giving him a chance to upload again. But that doesn't apply to everybody. You always have to submit your assignment on time. Only in unusual situations I will allow later submission. All right, that solves that. I'm moving on to next topic. Lecture 5. Now, I am going to show you how to work with the software in the next class. So next class, I'll be ready for that. It's just that I have to bring in that Windows computer here and set it up with the Zoom and everything. And I was having trouble with this setup, but I will have it ready for next class. Okay, so, but you're not fully ready to write the program anyway, so it's a good idea to do it next class. So doing 2.2, which is variable types and C++ statements. So the program, we wrote sections of program already, very simple programs. And they're not complete yet. There are some additional statements we need to write, and we're going to understand those in this section. Then at the end of this section, we'll be ready to write a complete program. Only after that, we'll be actually ready to run the program. So what are these additional things? The variables that we introduce in our program have to be declared, and the declaration is what we need to understand next. One second. Okay, Muhammad Rahman, who just came in. Were you here before and you were locked out or something, or just came in? You just, all right. I guess he's not here yet. All right, let's move on. So variable types have to be declared, and so we need to understand what variable type would be for a variable. So let's go into that. First of all, the variable names, we made the names and used them in the program. We made up names for the variables and used in the program. And I said, there are some rules as to what can be a variable, but almost everything you make up is an acceptable variable. That's what I said. So let's understand the rules and make sure our variable names are according to the rules. The rules are only lowercase alphabets can be used. Because the uppercase alphabets are reserved for constants, variables that are constants. That's coming up later. You will understand that later. So at this point, you need to remember that you can only use lowercase alphabets and numbers 0 through 9. You can use those. But the first character must be alphabet. So you cannot begin the variable with a number. It has to be alphabet. But you can mix alphabets and numbers, but the first first character must be alphabet. And then no special characters. So only special character allowed is underscore character. Certain reasons they allow that. After we start writing program, you will realize, you'll be able to understand why. but you cannot use any other special character like $ or mathematical symbols. None of that can be used within a variable. Only character other than alphabet allowed is underscore. Now, you cannot use keywords of the language. Keywords of the language, I'm referring to it as reserved words. You haven't learned any of the keywords. One of them you just learned, cout. Cout stands for asking for the output on the screen. And you cannot use that word as a variable name. So you understand that, right? There are some reserved words, keywords of the language. And we'll be learning some more keywords in this section. They cannot be used as variables. So that's what that rule means. Okay, so in summary, lowercase alphabets and numbers can be mixed. First character must be lowercase alphabet and not number. Underscore is allowed, and no other characters. And reserved words cannot be used. So those are the rules. All right, going on to next slide. So here I'm using a variable name num1. That is valid variable. To store the 75 in a memory cell, I write num1 equal to 75, and that is correct. So when this statement is compiled, remember, program will be translated to machine language by compiler. Only after that, the program will be ready to execute. So even though we are writing it as num1 equal to 75, when the compiler translates that line, it will actually convert 75 to binary code. Only binary code can be interpreted in the computer. So that's why we don't have to convert that 75 to binary code. We can write 75 in our program. So why did we learn binary coding? To understand how the memory works and how to determine how much memory is needed and things like that. You need to understand the binary coding. That's why we learned it. But when you're writing program, you will write the number in decimal code. The compiler will convert 75 to binary code, and it will store the 75 in the memory this way. Right here, this picture shows exactly what will be in the memory when 75 is stored. The binary code of it will be stored. So we don't have to worry about the binary coding. We can write this statement this way. So now our question is, what are the valid variables? So here's my example at the bottom. X is valid variable, total money. See the underscore I have? So we use the underscore when we need to join two words. When we are trying to use meaningful variable names, sometimes we need to join two words, and you cannot have a blank space as part of the variable. No blank space. So I have to use underscore to join the two words, total money. Sum is a valid variable, num2, char10, first val, these are all valid. Now, fourth num is not valid. Why is this invalid? Anybody?
It has to start off with
Yeah, it has the
the
number in
character
front.
needs to be an alphabet first. Yeah.
Number beginning with a number is wrong. So that you not begin with a number. Dollar value. This is wrong because $ cannot be used. You cannot use any special character. You can only use alphabets and numbers.
Guys, mute your mix.
I'm sorry?
No, not to you, Professor. I'm talking to my classmates. I'm asking them to mute the microphones.
I'm having a trouble understanding you. Probably your microphone is poor. That's what I think is happening. All right, I can't understand what you're saying.
He was just telling other people to mute their mics.
Put what again?
He was just telling other classmates to mute their mics.
All right, okay. All right, please, everybody, if you're having some noises in the background, please turn off your microphone. That way it'll be quieter. Thank you. Okay, going on to dollar value, it's invalid because it has the special character dollar. Cent will be also invalid because of the cent symbol. X plus Y is invalid because of the plus symbol. No special character can be used. So let's go on to next slide. So always use meaningful variable names. That way you will know exactly what you have in each variable. You know, it's helpful for the programmer and for any reader to understand the program better. So if you're using a variable name to store operating cost, then use something like op cost. Because operating cost is a too long variable. You know, long variable is a bad idea too. You have to type that over and over in your program. So you can abbreviate the words. ID number can be stored in ID num like this, instead of using identification number. You cannot use identification number. You cannot have a blank. There's no limit to the number of alphabets or number of characters you can have in your variable. It can be of any length. But, you know, why would you want to use a long variable like this, identification number? That's, you know, even typing it would be too much work. To store the name of a customer, you use the word customer as the variable name. So meaningful variable names will be always a good idea. So each C++ statement in computer program must end with a semicolon. If you have an assignment statement, you can only have a variable on the left side, an expression on the right side. You cannot have an expression on the left side. So let me go to the board and write something to explain something. So let's say I wanted to write Z, or I wanted to add two variables X and Y and put the answer in Z. Then instead of writing Z equal to X plus Y, I write X plus Y equal to Z. This is wrong, right? The assignment goes in this direction. So you can only have variable on the left and expression on the right. And I failed to do that. I have expression written this way. So what would happen? The compiler will not be able to translate this. And what do you think the compiler would say? Where exactly would be the problem for the compiler? Compiler would recognize the problem as what? Anybody?
It would say that the variable is invalid.
Exactly. It will say the variable is invalid. That's very good. You found the right answer. The plus symbol cannot be used, so this is invalid variable. That's what it will say. That's exactly why the plus symbol was not allowed in the variable. Because if plus symbol is allowed in a variable, it would accept this as a variable and will copy the value of Z into this, right? It will interpret this as a request to copy Z into another memory cell and name it as X plus Y. We don't want the compiler to interpret this that way. We want the compiler to recognize this as a problem, as an error. That's why the plus symbol is not allowed in the variable name. So there's a reason for all those rules in the variable name. All right, going on to assignment statements one more time. I explained it before. In an assignment statement, you can only have a variable name on the left side and expression on the right side. The expression means it can be just a number or another variable name or a mathematical expression. Anything can go on the right side, but left side must be a variable name. The equal sign here is an assignment. It says assign this expression to this variable. It's not an equal sign as understood in a math class. You know, in a math class, equal sign is used for equality. That's not the case. Even though it's somewhat similar, it's not the same. So let's look at yeah, what's on the left side must be qualified variable, must qualify as a variable. Only then your statement is valid. So some of your homework questions will ask you, whether the statement is valid or not, and then it'll ask you to explain why it's invalid, if it is invalid. Okay, so let's answer some questions like that. Is this valid? This is valid. No, there's nothing wrong with this. Operating cost equal to A/B times C. That means divide A by B and then multiply by C and store it in operating cost. And that is also valid. Profit equal to revenue minus cost. Valid. Dollar equal to cent over 100. Valid. Customer equal to J in single quotes. If you have the single quotes, then that character becomes valid data. So these are all valid. So let's go on to understanding data types. So whenever we use variable name in our program, we need to determine what type it is. So what data type it is. So to determine what data type it is, you need to determine what type of value will be stored in it. So the data type of a variable is same as the data type of the value you're going to store. So you remember there are 3 data types. Anybody remembers the 3 names of data types?
Integer, float, and
Character.
Yeah, characters, yeah.
Integer, float, and character, right? Very good. I'm glad to see that you remember those names. So 3 types we have already learned. There are more types that will be coming up later. So the details of how to determine data type, that's what we're going to discuss next. Data type of a variable is the same as the data that's going to go in it. So you first decide what type of data you're going to store. If it is going to be integer, then the data type of the variable will be also integer. If the value is float type value would be a value with the decimal point in it. Then you have to use your data type of the variable is also float. If you're going to store a character, then it will be character type. So once you determine the type, you need to use a keyword to tell the system that this variable is of this type. So the keywords are float for floating point type, int for int type, char for character type. So these are the 3 keywords you will be using to identify your variable as one of these types. And it is required that you identify the data type of your variable and indicate that in your program. So you need to write this statement like the following. Let's see the statement. The statement will indicate your variable as a float type or int type or char type, one of these. And that statement would look like this: float, upcast, semicolon. So this statement I must write somewhere. Usually we write them at the top. This declaration statements, we write them at the top. This will basically say, I'm going to be using variable name upcast to store a floating point number in it. That's what you're saying to the system. And it needs to know that before you use that variable. So before you use the variable name upcast, this must be there. So you need to put this at the top. Normally we do all the declarations at the top. That way system has all that cleared up right up front. If I'm going to store integer in the ID num, then int ID num. You need a space between the keyword float and the variable name upcast. You need at least 1 space in between. If you have 10 spaces, that's still fine, but minimum 1 space is required, and it'll end with the semicolon. Int ID num ends with the semicolon. Char val. Val is going to be a variable to hold a character. Then the keyword is char, not you cannot change that. Some students write character. No, that's not the keyword. Char is the keyword. So val will be used to store a character. That's what it means. So every variable you're going to use must be declared at the top of the program. Only after that, the variable will be accepted in the program. So if you miss the declaration statement, compiler would find that as an error. And whenever you use that variable name, it'll tell you this is invalid, it was not declared. So declaration is necessary. So here is a bunch of declarations. If I have a whole bunch of variables, 3 variables that are going to be float type, I can write one statement, float upcast, comma, val1, comma, val2, semicolon. You don't have to write individual statements. You can put all of them in one list. Even if that list goes into second line, that's fine. Your line can be broken up. Only the semicolon indicates where that instruction ends. So if this instruction extends through 3 lines, that's okay. Only semicolon will be at the end. And so I have an example right here. Int, I have a whole bunch of int type variables. So I have a long list and I extend it to second line and I have semicolon at the end. So as long as the semicolon is there, it will connect these 2 lines as one statement. Char val ch1, semicolon at the end. So in one program, you can have all of these at the top if these are the variable names you're going to use. So normally, if you look at a program, at the top, you will see these, all the variables declared. And that's exactly how I would like you to do it. Put the declarations at the top. Don't do it in between. It's not a problem for the system, but for a reader, it'll be confusing. If you declare all of them at the top, then the reader will be able to find it easier to follow your program. You have to remember, the program you write is not only going to be read by you, others will be reading it. That's the understanding you have to have, because in the programmer's world, people work with other people's program all the time. So you need to keep that in mind. So here are some invalid statements, declaration statements. I want you to, yeah, we can, it's already described here. So float fifth value. What's wrong with this statement? Well, the variable is invalid, right? It begins with the name, the number. So variable name is invalid here. Nothing wrong with the keyword float, but the variable is invalid. Now this one says int float. So it's declaring the word float as a int type variable. Remember, the keywords of the language cannot be used as variable. So that's the problem here. You're using the keyword float as a variable. You cannot do that. So you have now learned 3 keywords, float, int, and char. They cannot be used as variables. So here is a declaration, val21 and val22 are character type. What's wrong here? The keyword should be char, not character. And that's the mistake here. Okay. Always interrupt me and ask you a question if you have any. Going on.
I have a question.
Sure.
So you want us to declare all of the variables that we're going to use and basically their types in the beginning of the program?
The beginning of the program, exactly.
So even before we create them, right, we have to declare that this is the type of data type it is?
Before you use them. That means even if you're going to use a variable, like 50th on the 50th line, you still declare that variable at the top. Okay. So whenever you need to introduce additional, let's say you're writing the program and you realize I need to add a variable. If you need to add a variable, then go to the top and add the variable in the declaration also. Okay. And
so Professor, so you're saying that declaring it and initializing it all in one line is difficult?
No, it's valid. Yes, I
Okay.
haven't got to that yet.
Oh, okay.
Yeah, I'll get to that in a minute. You can declare and assign at the same time. That's coming up later. Okay, so declarations must be at the top, and declarations are required. Otherwise, compiler will complain. When it tries to translate, it will recognize that a variable has not been declared, and so you need to do that. So no monkey in the bird nest. Basically, I'm using that term to tell you that if you declare a variable as character type, you can only store character in it. If you declare a variable as integer, you can only store integer. If you declare it as float, you can only store float type value. No other values can be stored. So what will happen if you try to store other types? That's coming up later. So here's an example. In this statement, I'm going to store 560 and 8 in 2 memory cells. To do that, I have to begin by declaring int upcast and val2. The names, you make up anything. And then upcast equal to 560, val equal to 8. Those are 2 statements assigning the values. But before assigning, you had to declare the variables. So after these statements are executed in the memory, you have the values stored like this, 560 and 8. Okay. Here's another example. I want to store the character and the ampersand symbol in the memory. So I declare a char type variable cval, and then cval equal to and. There are questions in your homework similar to this. Write a statement to store the character ampersand in the memory. If you just write cval equal to ampersand like this, it's wrong because this is required. Before storing, you must declare. So if the variable declaration is missing, then this is considered to be wrong. So you need to write both statements to answer the question. Can I assign value in my declaration? Yes. So we don't have to write them separately. Upcast is going to have 560. I can write that this way. Int upcast equal to 560, comma, val2 equal to 8, semicolon. So 2 variables have been declared here, and both of them have been assigned values, all in one line. That is valid. So therefore, the second statement we wrote, the second example we had in the previous line, here these 2, I can combine these 2 also into one. Char cval equal to ampersand. Remember, ampersand must be in semicolon, in the single quotes. Let me, this is time for me to explain something. So I'm going to the board and I'm going to explain something here. Let's say I want to store, the question says, write a statement to store the letter K, that doesn't matter. Store K in memory. That's our question. Okay, then you have to declare the variable as char, and then make up any name, right? Val, I made up the name val, and then equal to K. And I forget to put the semicolon, the quotes around. What would this system interpret this as? Will this be an error? I wanted to store K in the memory, and I wrote the statement. Only thing I missed is the quotes around K. So is this going to be recognized as an error by the compiler? Or if it is, then what would it say as error? Anybody see that?
The compiler would. Yeah, go ahead.
Sam, go
I would
ahead.
say it's an error.
Error?
Yes.
Okay.
I think it's going to look for a variable by the name K, and then if it won't find it, then there will be an error.
Exactly. Well, that's right. It would interpret K as a variable. It'll take this statement to mean copy the value of the memory cell K into val. So if there is a variable K used anywhere, then this will be valid. It's not going to recognize that you have a problem, that K is not correctly written as a data, it will recognize that as a variable. That's exactly why for a data K, a code is required. Otherwise, K will be interpreted as variable. Okay, so if K is a data, you need quotes around. If the quotes are missing, it'll interpret that as a variable, and that will be a disaster. The program is not going to be right. So these things are designed so that when we write program, the program will be correct. We'll be able to write the program correctly without too much trouble. That's why these rules and everything are there to make sure things don't go wrong. You need quotes around the character data. And also remember, multiple characters cannot be used together, like kite, in single quotes. Can I use this as my data in a program? No. If you want to use the word kite as a data, then you have to make it a string. The string will have to have double quotes, and then it'll be a valid data, but we haven't learned how to handle strings. That's the topic of 270, Math 270, Computer Science 272 class. So we will not deal with that. So you cannot write kite with the quotes around. And no more than one character can be used as data in this class. So if you want to use names of people as data, they have to be strings, and how to handle them will be a topic of 272. Okay, move on. I already explained this. If you want to display a value of a variable on the screen, then you write cout, and then this arrow. The inequality symbol must go in that correct direction, and then variable. Do I need space, any space in between anywhere? No, not really. But normally we write a blank space here and a blank space here, just to make it easier to read. Cout, and the variable can be, any variable name. The value of that variable will be displayed on the screen. So here's an example. If I have a variable name ans having 14 already in it, and if cout ans is executed, then the 14 will be displayed on the screen. That's what it does. Just the 14 will appear. Where would it appear? Wherever the last writing ended, wherever the writing cursor is. And that can be, usually, you would know what is displayed on the screen. And if something is already displayed on the screen, then the 14 will go right next to it. So it can be hard to read at times if there are already things on the screen. So therefore, we need to sometimes add things to our output. And I'm going to explain that in the next few slides. If I have 5 and 2, this is my example to explain how to get the output properly written. Int m equal to 5, n equal to 2. All right, I think I have to stop it here.